Bambu Lab P2S combo. Enough intro, let's go! Let's get that thing unboxed. First, let me tell you, after reviewing many of these big and heavy printers this year, my bag was very happy about unboxing a standard-sized printer like the P2S this time. And it's a typical Bambu Lab experience. There is the quick start guide which guides you through unpacking and first-time setup, an accessory box with some tools, lubricants, fasteners and spares. Unfortunately, Gen 2 single nozzle printers don't get spare hot ends. That's a pity. The rest is business as usual, lifting the device out of the box and unwrapping it. First surprise? No more carbon fiber rods for the X-axis. We have a closer look on that shortly. Inside the printer we find the AMS2 Professional and the accessory box, with a novelty for the P series. The Gen 2 color touchscreen we already know from the H2 series, but with X1 hinge. Resolution and user interface is identical. Also that choppy performance when scrolling thumbnails of prints. And there is a new camera for the chamber, now at 30 fps instead of sub 1 fps. They also altered the angle, now pointing more directly towards the print and less on the toolhead. Time-lapses profit from the improved camera and the better lighting as well. And there is a new spool holder for the P2S and PTFE tubes for the AMS. This time I actually had to check the quick start guide on how to get the P2S set up, as it's a bit different. The AMS is well secured inside the machine and there are cable ties as well as foam to secure gantry and toolhead. The AMS only contains the desiccants, which, by the way, don't help much to keep filaments dry, and there's some foam. By the way, the glass lid and also therefore the size of P1 and P2 series stay the same, but there are differences in height and space requirements. Quick look at the bottom reveals a similar layout for the Z-axis as first gen, and that space used for grabbing the printer, I totally dig that, also functions as air inlet for the cooling system, at least at the right hand side. That new adaptive airflow system is worth a closer look, we do that in a minute. On the left side there is space for an optional second external part cooling fan. I am curious what you could get out of that machine with two external fans blowing from the left and the right. Reminds me on my 24/7 Zero. Dang, I need to go back at it, right? The P2S also comes with those new wobbly feet now, so please excuse the shaky printing footage later. While setting up the rear for AMS use and spool holder, we see some obvious changes and updates. Most importantly, there is a new filament buffer with two inlets. At default usage, one for the filament on the spool holder and the other for the included AMS of the AMS combo. That means no more switching back and forth between external and AMS use like in first gen. Though more space is needed between printers next to each other if you want this all-in-one situation permanently. The standard P2S without AMS does not come with the new filament buffer, and it has to be bought separately if you want to use an AMS later. That also means the Gen 1 buffer is not compatible with the P2S. That's a pity, but the old AMS units can still be used on P2S if you buy the new buffer. The PTFE tube for the spool holder seems a bit short for my taste. And by the way, the P2S can connect up to 4 AMS2 Pro units and up to 4 AMS HT units at the same time, meaning it can access up to 20 filament slots. But please, let's not call this 20 color printing. First start, setup and calibration are as usual. Automated, easy and convenient. The obvious first Benji print came out nicely as well. Having P1S and P2S next to each other shows a new color scheme, my Birkenstock, and way brighter lighting for the P2S, as it comes with two brighter LEDs now. One at the left and one at the front. Now take the following absolute lux values with a grain of salt. I might have to refine my measuring methods here, leave a comment if you have hints for that. Though measuring lux at the same spot and in a dark room shows a huge difference between first and second gen P series. The way larger H2D with LEDs on the left and right even shows a lower value than P2S. And yes, subjectively, without measuring, it's obvious that P2S is very bright. The P2S also grew in height. There is a height difference of around 10 mm. That mostly comes from the new toolhead and second gen nozzles with the quick swap system. The overall geometrical package at the bottom might have an impact as well there. In comparison, the layout at the rear especially shows the lack of an exhaust fan. Anything else, power inlet with switch, poop chute, perforation for the venting of the electronics department, the refresh PTFE filament inlet, all roughly similar concerning position, though with slight changes. What's new? There are 3 positions for spool holders, taking into account that you can use the P2S with the new buffer and AMS, without AMS, and also a position for default P2S without the buffer. At least that's my assumption for now. Comparing both P1S and P2S under the hood also makes clear the package has not changed drastically. There seem to be a lot of Gen 1 synergetic parts concerning the frame as well, but there's a lot of refinement and we see 2nd gen electronics. Important note, as we see the guts, there is no wiki online yet, but according to Bambu Lab, repairs on defective idlers should be way easier now. That drama should be eliminated. Concerning connectivity, we have an USB-A connector near the touchscreen, needed for a USB drive which stores time lapses and print files. To get that additional LED at the front integrated, Bambu Lab ditched the breakout connectivity behind the touchscreen on the inside. And that's basically all concerning connections. No Ethernet unfortunately, and again, also no exhaust at the rear. The new airflow system has a noticeable impact. It's an interesting integrated concept we have here, but might also raise some concerns. First of all, it has 2 modes, which are flap controlled, serving 2 purposes. In cooling mode, it acts as the auxiliary part cooling fan, this time from the right, sucking ambient air from the outside. It doesn't just recirculate like the Gen 1 auxiliary fan, the idea is to be able to keep the printer's door closed while printing low temp materials like PLA. By the way, the P2S now features a sensor for the door as well, which can be set to just leave notifications or to pause the print, just like on H2 series. The air might just result in being pushed out through the holes and gaps of the machine. That seems to work, but somehow doesn't feel like a really good solution here. But yeah, I get it, the package is limited and that concept wouldn't work otherwise, as the 2nd mode, the heating mode, is there to help heat up the chamber quicker, for keeping the heat and for improved air filtration. While recirculating, the 2 flaps are closed, the one heading to the outside at the bottom and the upper one leading the airflow to the aux fan outlet for the park cooling. Therefore, that blower fan sucks the air through the newer bigger filter, which includes both HEPA and activated charcoal components. The filtered air gets sucked at the rear right and blown out at the smaller outlet positioned around 100 mm below the nozzle. And here's where I have or had concerns. At some point the print gets blown at with air conditioned to inner ambient temperature. Though I did a quick test with this wader head, printed from ABS, which worked well. And thinking about it, for example at 0.2 mm layer height, that's after around 500 layers, the print should have been already cooled down to inner ambient temperature. Bambu Lab, who probably did way more testing on this, didn't share my concerns. What do you think about this? Leave a comment. I still have mixed feelings about bigger engineering grade prints being blown at. Also, that new big filter component surely is an improvement over 1st gen, but I can still slightly smell ABS fumes when being around while printing. Nope, still smelling. Because, as we've learned, the chamber can't be airtight. I'm still waiting for a printer I can print ABS on without having allergic reactions or headaches. Anyway, heating up the P2S chamber passively with the print bed is way quicker now with that flow system than on 1st gen. In my test scenario, I positioned the print bed at the resulting location after homing, with the bed heated to 110 degrees Celsius and the adaptive airflow system set to heating mode on P2S. I used the X1 Carbon here as the P1S doesn't have a chamber temperature sensor, but conceptually they're the same, though the X1 Carbon can go 10 degrees Celsius higher in bed temperature, which I used here. The heat-up times of the chamber P2S versus X1 Carbon are significantly faster with the recirculating cooling system used. That's a nice improvement and will make a difference later compared to P1S, which I didn't expect. The P2S print bed heats up very fast. Measured on the sensor, it takes only 35 seconds to heat up to PLA temperature. Less than 1 minute for reaching 80 and 1 minute 20 seconds for 100. The maximum temperature of 110 degrees Celsius is reached in way below 2 minutes. So in comparison to the already fast 1st gen, there's noticeable improvement. For the thermal camera measurements, I took off the steel sheets this time, as that can mess with the measurements. On a side note, the build plates for P2S have a new coding for auto detection on which type is used, but the old build plates used for A1, P1 and X1 series still work for printing, though not for the auto detection. Temperatures on the surface lag a bit behind on the P2S, but not on the P1S. Maybe they changed the sensor position for the new print bed. I have not disassembled it yet, but maybe Vector 3D did? All in all, it's looking good concerning max temperature reached at the center. Difference between center and edges is between 5 to 10 degrees Celsius, depending on where you measure exactly. Not great, but seems like the standard nowadays. A first layer test showed a basically flawless result, equal and even throughout the whole surface. The nozzle probing and bed meshing works well here, and throughout all printing I've done, first layers were consistently good with all materials used. That brings us to the motion system and toolhead, both with novelties as well. First of all, Bambu Lab ditched the carbon fiber rods and now uses hollow steel rods for the x-axis. Many users will applaud for this move as it makes sense concerning maintenance and repairs, but weight increases. According to Bambu Lab, the weight of the X-assembly, therefore toolhead and the rods, but without the XY joiners, which should be the same, increased by around 120 grams, which is significant. That's why the P2S also got beefier motors, according to Bambu Lab, which unfortunately also show more pronounced VFA if you provoke it, like we do later. The first-gen carbon rods were just 48 grams, whereas the hollow steel rods are 160 grams. Toolhead weights are roughly the same on P1 and P2 series, even though the second-gen toolhead is a bit higher all in all due to the new quick-swap nozzle system. The high-flow nozzles can be used on the P2S as well. All the other second-generation improvements like the Dynasense servo motor extruder and the eddy current flow calibration come with P2S as well. Other than P1 series, P2S now also come with a hardened steel nozzle by default. Blower fan for part cooling was beefed up as well. While still operating at 24 volts, the P2S fan peaks now at 0.38 amps over 0.15 amps on P1. Overall, these are significant changes on the motion system and toolhead, though slicer settings for P2S left me a bit confused there. All speeds and cooling related settings seem unchanged from first generation, except for travel moves on the P2S, which increased to 600 mm per second. I would have expected the Gen 2 hotends performing roughly the same when comparing H2S and P2S concerning flow rate limits for standard flow, but also concerning high flow. Also, that P2S high flow value for PLA Mati might be an outlier which needs or will probably be corrected. Long story short, I asked about this. The current settings are intentionally conservative, but they plan to gradually optimize and enable more aggressive strategies in the future. That also means for the printing tests that follow, it doesn't make much sense to compare print times at the moment, as they are the same as P1S or X1 Carbon. Before we get into that, the latest news and offers from today's sponsor, PCBWay. First, their Mascot 3D printing design contest is still open for you to participate. You can submit either a design based on their mascot Eon or your own original character, and winners receive cash prizes. First place gets $500, plus coupons and certificates. Shortlisted designs may even be professionally 3D printed or featured. Second, throughout September and October as well, PCBWay is still offering their purple soda mask at no additional cost. That means you can add visual flair to your PCBs without paying extra. Check out the link below and visit PCBWay.com. Some disclaimers beforehand. First, I usually don't tweak settings to optimize results for testing, and that's on purpose. My goal is not to show the nicest prints possible. I show what the user gets out of the box and by slicer default. I expect manufacturers to test their machines and settings accordingly for their filaments, and also for third-party filaments using the generic settings. Second disclaimer, on multiplexer machines like the P2S, I don't do multicolor test prints anymore, as waste and print times are through the roof with these machines. An AMS unit is great to have quick and convenient access to a range of filaments, but not for multicolor printing when using one toolhead or nozzle. Last disclaimer, all filaments, without exception, also PLA filaments, are dried beforehand and kept dry during the printing. Even for PLA, that makes a difference. This time we start with that part from the 24/7 printed printer and reprint it from shiny black PETG. I like to choose this one to test coarse layer performance and to expose vertical fine artifacts. And like on so many other printers, VFA are quite prominent on the P2S as well, especially on the x-axis but also on the y-axis and the motor axis. For anything else, this print is fine, but let me dig a little bit deeper into the VFA topic. VFA can have different sources like the motors, motor drivers, or the pitch of the belt used in the motion system of a printer, a very complex topic of interacting factors. Also, depending on the print speeds. Prusa's Core 1 is or was hit hard by VFA as well, and they did some research on that topic. Joseph wrote a nice article about that, worth reading, linked below. I am absolutely no expert here, but I wanted to compare Bambu's first generation to Bambu's second generation, as the P2S got new motors and probably also new motor drivers. I made a little test print which tests the X and Y axis as well as the 45-degree diagonal axis. In a Core XY setup like here, that's the axis where only one motor is moving the gantry. To visualize the speed dependency, I used G-code height modifiers to gradually increase speed in 25 mm per second steps up to 400 mm per second. I set the max possible flow rate limit in the filament settings to actually be able to reach the set speeds. To not exceed flow rate limits too heavily here, I went with 0.12 mm layer height. I used 4 walls to have acceptably low layer times for that shiny PETG I'm using. Watching the prints for this going on makes you wonder how bad print quality actually is on P1S and P2S. For shiny filaments and certain speeds, that's true for sure if you provoke it. So let's compare P1S and P2S to see if there was a quote-unquote generational refresh. Looking at the x-axis, we realize the P1S print turns matte at around half of the height. The P2S does that way later and stays shiny for way higher speeds. Speaks for increased flow rate capabilities of the second generation printers. What follows are quick and dirty assumptions and observations. Correct me in the comments if you know better, I am open for that. First, I assume that VFA could get ironed out on P1S due to lack of flow rate at higher speeds. That's why P2S seems more shiny and a bit more cluttered. Also, VFA on the x-axis seemed to be more pronounced on the P2S up to 150 mm per second, except for 125 mm per second. On P1S it's roughly at the same speeds, but way finer. Might be a different source of VFA, maybe the first gen motor driver or different resonances might hit or overlay here or whatever. The y-axis is a bit different. The VFA are way finer on both, and we have a similar situation from glossy to matte while speed is increasing. The 45-degree diagonal axis, therefore the one motor axis, is quite scattered on the P2S and rather gradual from low to high speeds on the P1S. You might think now, alright, interesting, but what's the takeaway? First, you'll have more or less pronounced VFA on almost all printers nowadays, depending on the filament used and depending on the speed used on each layer. Second, the P2S seems worse concerning VFA than P1S, but it's also different in its appearance and it's always speed dependent. As mentioned, it might be the new motors, new motor drivers, or maybe internal stepper driver settings which aren't as optimized yet for the new technical situation as on P1S, just as the slicer settings. The good news is, there can be solutions. Prusa already did a lot of work here. Wink wink, Bambu Lab. Anyway, let's do some more printing and you can try and spot VFAs there. Let's go on with that KSR test printed with Bambu Lab's PLA Basic. Therefore, should be optimal conditions for the P2S and it looks good. Tolerance test pins came all out easily when detaching from the print bed. Those needles at the top are flawless. There is literally no stringing. Try and dry your PLA if you have stringing there. Overhangs came out well, though that bridge there is a bit sagged. The bridging at the bottom is okay as well. No complaints, very good result overall. The P1S always was a good performing printer and that shows with the KSR test as well. To be fair, I did that print with the door open. Results are quite the same as on P2S, using the same filament and the same settings. Perfect needles, no expected surprises. Modern printers can do this. Next, a beautiful PETG challenge with that Voronoi deer printed with Voxel's PETG. A wild retracting and stringing challenge. Looks good as well. Profiles for generic PETG seem to work too. Can't complain much. And keep in mind, that's a very fine structure here. Now we test the generic TPU profile with my good old SaneSmart TPU filament. That cat is an established standard for my tests and demands heavy retracting. Modern printers can handle this one meanwhile, but with more or less stringing. If you want to try that yourself with your printer, as always, links to models can be found in the video description. Make sure to dry your TPU beforehand. The result on P2S is very good. Naturally, there is some stringing, but the result is among the best I've seen so far. H2D and H2S were worse here concerning stringing. The Prusa XL was best so far for this one, though P2S seems just as good. I also tried on P1S and got quite the same result for this cat. Maybe even a bit better. Bambu's P-series printers seem to be great TPU performance as it seems. As the desiccant bags coming with the AMS2 Professional are worthless for keeping filaments dry in my opinion, I printed a full bed of those dry pods for all of my AMS2 units from ABS to not have problems with the drying function. The results are fine from my perspective, the support removes nicely and print quality is okay in general. Maybe a bit under extruded, which can be fixed easily in the filament settings. The lid slides in nicely and the hygrometer is a good fit there. Finally, I can keep my filaments dry in the AMS2 Professional. Okay, I promise that was the last time. Last but not least, I tried some engineering grade materials on the P2S and compared it to the P1S, polycarbonate, PA6 and PPA-CF. The latter only on the P2S though. I assume the P1S is able to print PPA-CF just like P2S, but I ran out of time, sorry. The prints came out with surprising results. I haven't expected a difference that noticeable. The parts I printed contain rather long parts and short parts as well for the conveyor of my other 24/7 prototype from 2020. All of them prone to warping from my experience, especially the longer ones. On the P2S, the long polycarbonate part came out with minor warping. Honestly, no big surprise, I expected that. Fiber reinforced materials are a better fit for that. I expected the same result for the P1S, as it's enclosed and standard bed temperature for Bambu Lab's PC filament is 100 degrees Celsius here as well. But the longer part came out noticeably more warped in comparison to P2S. As recommended, I used glue stick for both prints. Concerning warping, the results for the PA6 print are quite similar on both. Though surface is rather rough on the P2S result and there's those strings on the top of the surface. I just realized the difference while editing the video and can't do further investigations unfortunately. The filament was bone dry for sure and settings should have been the same. The result on the PPA-CF print on the P2S is nice and flat. Fibers help against warping. For a new iteration of my conveyor, I'd use PPA-CF as it takes high temperatures and high loads, a perfect fit. Summed up, it seems like the air recirculating heating mode of the P2S is more beneficial for high temperature printing than I assumed. At same conditions, it shows less warping than P1S. And here's a message from editing Albert. I didn't preheat the chambers for those prints. This could have made the difference here. As we've learned before, P2S heats up quicker and these were rather short prints here. While printing, I took the chance to measure noise emission on P2S. As always, 50 cm from the printer. Results are as usual for nowadays printers. Not exceptionally loud, but not super silent either. It's an advantage that it can be kept close now for PLA printing as well. Today's intro was super short, so how will the verdict be? The P2S is basically an X1 Carbon, but with all the Gen 2 bells and whistles. All specs are the same or better, except for the 120 degrees Celsius bed for US customers. The new touchscreen, a better camera, the improved extrusion system, a revised X-assembly for better maintenance as well as repairs, and there's improved filament management at the rear. The new adaptive airflow system is clever and helps to improve chamber heat up and enables for printing PLA at a closed door. Print quality is at the same usual good Bambu Lab level we know. On the negative side, we have more pronounced VFA than in the first generation, which needs to be solved. Prusa is the role model. There are possible solutions. The adaptive airflow system could raise concerns for larger engineering grade materials as well. Having constant airflow on a high temperature print still worries me, to be honest. In certain cases, it might affect the cool down of upper layers for large prints. Concerning the beefed up cooling system and the higher flow Gen 2 hotends, there is still unused potential concerning slicer settings in Bambu Studio. Nevertheless, the X1 Carbon and P1S become obsolete, at least at current prices, and they feel dated looking at all the Gen 2 refreshes the P2S got. I am very curious about the following. First, how will Bambu Lab adjust the prices for the first generation, therefore P1P, P1S and X1 Carbon? Second, what will the X2 series bring to the table? Will there be a new X2 Carbon flagship? Why P2S before X2? Give me your bet on this in the comments. Thanks, that's it, you know what to do, and there's an affiliate link in the video description. Servus and bye bye. Thank you, Shulo!